My name is Tomáš Antecký, and in the next several minutes I would like to introduce you into radare2. Before I'm going to begin, I would like to mention that this presentation can be found in this link, so you will find that everything that I'm going to show you today. This presentation is divided into two main parts. First, there is a quick introduction into a radar, and secondly, there is going to be a live demo. So, what is the radare2? It is an open source reverse engineering framework which is primarily used for static and dynamic analysis, binary patching, forensic analysis, and many more. From a user perspective, it's a set of static and dynamic, it's a set of libraries primarily written in C, and it runs on many different platforms, so it will definitely work on your platform as well. Speaking about supported binary formats, there is plenty of them, and also the support of architecture is pretty wide. Just name a few: we got x86, MIPS, ARM, or AVR. It's worth noting that the radar is able to handle tempered binaries, which we'll see in a demo as well. And this set of libraries is primarily used through command line interfaces, but there are projects which are focusing on development of graphical front ends. It's also very interesting that the whole suite you are able to script the whole suite by using languages like Python, Ruby, JavaScript, and many more. Installation of radare2 framework is pretty straightforward, but it's quite likely that packages inside your distribution are going to be obsolete. So the best way is just to clone it from GitHub and then install it by running provided shell script by user-wide or for the whole system, which of course requires root privileges. Language bindings are installed separately, and it depends on your choice, on your favorite language, but you have to install R2pipe package. On the following slide, you can see several sets of binaries that are in this suite. For example, we got tools for binary identification, binary diffing, inline assembling, and disassembling. There is also a package manager called R2PM, which can be used to install plugins into your radar suite and extend its functions through it. The main application is called just simply R2, which has shell-like interface, and it's able to you are able to use several shell features inside of it, like file redirection, command redirection, tab completion, and many more. Now I'd like to move into a second part, which is a quick demonstration of radare2 capabilities. Our goal is going to be obtain a password from a binary. Sometimes this type of challenges are called crackme or CTF challenges. Everything that, as I mentioned, I'm going to show you today is in the GitHub. So there is also a source code of this binary, but we will see how it works in a while. And also, there is no worries for if you don't catch anything, because every step that I will perform is in this presentation as well. So now let's move to demo. Okay, so let's start with rabind tool, which is a binary identification tool, and our binary is simply called runme. As you can see, there it is ELF 64-bit binary running on Linux, and there is nothing really interesting from these properties. Maybe that the binary is statically linked, so it's not using any shared libraries. Okay, so now let's run it. And it is asking us for a password, so just enter something. And then we are waiting several seconds, and then, as you can see, we are wrong. The password is wrong. All right. Before I'm going to use radar, I will just use ordinary tools inside Linux. So, for example, object dump, and run it to disassemble it. And as you can see by now, file format not recognized. Okay, that went well. Let's give a shot at GDB for dynamic analysis, of course. Okay, GDB starting, run it. Oh, and no executable file specified as well. Okay, so now let's try a radar. I'm going to use R2 command and the binary. And as you can see, the radar map library, and we are ready to go. The most important command is just question mark, which shows you context help, when you can see each commands are divided into groups. So for example, commands starting with I will provide you information about your binaries, P is for printing, and so on. So now I would like to see more commands for binary identification. So just I will write I question mark, and now I will obtain the whole commands that are here. By running just a simple I, there are exactly the same information as provided by Rabine. As was mentioned yesterday, JSON is pretty popular, so by appending J, I will obtain the exactly same information, but in a JSON format. I can prettify it as well, so it's much more readable, as you can see. When we obtain some unknown binary, it's always a good idea to search for unknown strings. This can be done in radar by running command izz, which displays whole strings that are inside this binary in whole segments. And as you can see, these strings are Unicode or ASCII, so it is scanning in one shot for these strings. Maybe we would like to know what segments are in this binary, and then we will limit our search of these strings. So there are actually two segments in this binary. The first one is read-only segment that is containing global variables, and the second segment called load1 is text segment, which is containing code. And quite interesting is that the write flag is turned on, which might signify presence of self-modifying code. So now get back to our strings, and we would like to just search for strings inside the data segment. So we can use internal grep for this task, which is just simple tilde inside the radar. Okay, and as you can see, there are 3 strings in the data segment, and none of them really looks like a password, so we have to try harder. By pressing V, we enter into a visual mode when the first one is just a simple hex view. By pressing P, we cycle through different views, and the second one is a disassembly view, which is pretty useful. Once again, if you don't know what to do, just use question mark, which gives you information about whole shortcuts in this particular view. You can move around it in disassembly view by using AJKL keys, so no surprise for Vim users. You can enable a cursor by pressing C and moving around as well. In order to run a radar command, just press colon, and for example, to seek to a beginning of the binary, just enter seek entry 0. Another very useful view is a functional graph, which is very common when we would like to analyze the control flow of the binary. However, in order to display it, we have to first analyze the binary. This can be done by running command AF. And after the function was analyzed, we can just by pressing V, enter into a functional graph when we can collapse each node, once again move around by using AJKL keys, jumping between each nodes and zooming out. And of course, we can switch between different views. For now, let's just focus on a static analysis of this binary. So I will jump back to its entry point. And as you can see, there are 3 syscall instructions right at the beginning. And the first syscall has number of 0, which you can also Google it. What does it mean? Syscall number 0, but of course you can use radare2 for this command, which translate this syscall number into its text form. And as you can see, the first syscall is write, which is writing something at this address to a standard output. And at this address, there is a string table of C strings terminated by 0 byte. So we can print this string once again by running print string 0 terminated at signed and the address. So basically the first syscall is writing password prompt into a standard output. The second syscall has number 0, which stands for read, and this syscall is reading password from standard input and is writing to a stack. The third syscall, which has number 23 in hex, stands for nanosleep, and it basically serves as really simple brute force protection, and it is sleeping for a given amount of time, and this amount is specified as tracked at this address. So let's examine this address as well. So X, @, and the address. And as you can see, at this address, there is first byte 3 and bunch of zeros. So it basically means sleep for 3 seconds. Just for demonstration purposes, we would like to disable this protection. This can be done by several ways, but the really simple one is by nopping out this syscall instruction, which is denoted by a cursor or this question mark. Before tampering with a binary, it's always a good idea to create its backup. So I just copy it from runme to runme.back. And now I will have to open this binary into a write mode, because by default radar is opening binaries in the read-only mode. Okay, and now we are ready to go. We will have to, as I mentioned, knob this instruction out. By pressing Shift A, we enter into a interactive assembly mode when we write instructions separated by semicolon. Syscall instruction is 2 byte wide, so we need 2 NOP instructions. And by pressing enter, we can see that these changes are propagated. So right now we get 2 instructions. 2 NOPs between one syscall instruction. In order to verify it, we can run radif tool, which is used for binary diffing, and the first argument is going to be our original binary called runme.back, and the second one is our modified one. And as you can see at this offset, these 2 bytes are different, and 9090 is in hex is NOP. Moving down to our analysis, we can see that there is a compare, which is basically comparing the first letter of the password with a hard-coded letter capital N, and if it's not equal, the code proceeds down, and there is a next syscall with argument 1, which stands for, as we already know, write, and is writing this string at that address. So it's writing string wrong into a standard output, and the second syscall with number 3c in hex is calling basically exit. So this block is responsible for exiting application if we provide wrong password. On the other hand, if the password starts with capital L, it's jumped to a different address where it is entering into a loop, and in this loop, this first character is used to XOR instructions that are below this address, because as you can see, the address here are just a gibberish. So it is decrypting this section of the code. Much more better understanding of this binary can be obtained by running a dynamic analysis. So let's move on to this. By running command OOD, it will start a binary with attached debugger. Now I'm going to place a breakpoint when the first compare is being done and run the binary. Now I have to provide the password, so some gibberish once again. And now, as you can see, we hit the breakpoint when the compare of the first character is being made. By pressing P, I can display CPU registers and the stack. And as you can see, there is the password which I have provided. And now I'm going to change it to capital L, which is the correct letter. So for C, add sign, and address at RSP register, which is pointing to stack. So right now we can see the first letter is capital L, and we can do several more steps to see how it is working. And as you can see right now, we are inside a loop, and the valid instructions are being emerging. So it's basically decoding what it's going to do next. After some time, you might see that this deciphered block is exactly the same as the previous one, except there is a second character of the correct password, which is 1 in this case. Manual analysis of this binary can be right now pretty tedious, so we can script this, and it depends on your favorite language. For this, I have used Python. with R2PM package, and this is the script which is basically doing the exactly same what we have already done. It is stepping each instruction by instruction, waiting for a compare, and then extracting a character of this password, writing it to a stack, and printing the password. Okay, so let's run it. So sol.py. I just redirect errors into dev null. Okay. And as you can see, the password is slowly starting to emerging. Also, it depends on the speed of your computer. But we got the password right now, and it is LinuxDays written in a fancy way. So let's try it. Run me password LinuxDays. Okay, so good job. Okay, so that was a really quick demo of the radar, what it's able to do. Finally, in the spare time, I would like to mention where you can obtain more information about radar and reverse engineering in general. The first two links are radar books, online radar books, which deals the whole functionality of this suite. The third one is a radar cheat sheet, which is pretty handy if you are learning it, and because it contains the most commonly used commands. Then there is a really wonderful book called Reverse Engineering for Beginners. It is open source, and the best of it is not just dealing with 86 reverse engineering, but it also covers ARM and MIPS as well. And the last link, which you probably might know, is a compiler explorer, which is able to, for given source code, most likely in C or C++, give you assembly from different compilers like GCC, Clang, ICC, MSVC, and so on. So that was my really quick presentation. Thank you for your attention, and now it's time for a question.